Assalamu alaikum warahmatullah. Okay, in this particular video, we are going to solve a simple question from your second PUC board. The question is regarding to the derivation of derive expression for electric field for a dipole at a point on axial line. So this is one of the most important questions for your PU board exam, which is usually asked for a 5 marker from your first chapter electric field. Okay, so how do we go forward with the solution of this particular question? So let us start with the solution. The first and foremost thing what you do is you consider two charges. One is negative charge, the other one is positive charge. The center of the dipole will be O. The distance of the dipole, the length of the dipole will be 2a, and along the axial line, meaning you take something like this, along the axis you take some point P which is at a distance of r from the center of dipole. Okay, so this is your figure. Then what else do we do here in this particular in this particular problem is, first we need to mark what are the electric fields which are involved. So the electric fields involved are, due to the positive charge at point P, you will have electric field away. I can mark it as E plus Q, electric field due to positive charge, and another electric field due to negative charge, that is E minus Q. In the opposite way, this is considered by considering as the point P is having some unit positive charge. Okay, considering that way, we get E plus Q away and E minus Q towards. You can also write E plus Q as plus I cap direction, E minus Q as minus I cap, or you have a simple approach, minus Q to plus Q charge has dipole direction. Vector P, dipole moment P cap is from minus charge to positive charge. So this is the basic. So for this, the explanation you write, I hope you know how to write the explanation. The explanation is simply initial introduction. What you write is very simple. Whatever you have drawn the figure, you will just write the same thing. Consider two charges plus Q and minus Q separated by a small distance 2a. Let the dipole with center O be placed at a distance r from point P on the axial line. So you have explained all the things. Let E be the electric field involved. So इतना बोल देने से I feel your introduction part is done. After this, how we start with the derivation, that is important. So let us move forward. First thing we write, from definition of electric field, we know that E is equal to 1 by 4 pi epsilon naught Q by R square. This is the formula for electric field. Okay, so once we tell this formula, we can now explain the further steps. First thing is electric field due to plus Q charge. What will that be? E plus Q is equal to 1 by 4 pi epsilon naught Q by R. Here is from point center to the, or should I say from plus Q to the point P. So that is from plus Q to point P. So this much distance. This distance is nothing but from the center minus this distance, isn't it? So clearly it is R minus A the whole square. Okay, and plus Q is in the direction of the vector, so P cap I can write. So similarly, I can write electric field due to negative charge E minus Q will be equal to 1 by 4 pi epsilon naught Q by R plus A the whole square times P cap with the minus sign, isn't it? So this is simple. Minus Q is in the opposite direction, so you'll write minus P cap. And distance, I think you can understand from now, minus Q charge and point P, it is a distance of, from here to here it is R. This much distance is half of 2a, that is R plus A is the distance. Okay, so with this we can move forward. Once you get this much, I hope you can just go through what has been done till now. So once this is done, let us move forward. How do we go forward with the next step? That is, Both the vectors, you know, one is in this direction, the other one is in the opposite direction. E plus q is like this, E minus q is like this. In this figure, if you observe, E plus q is more. Why is E plus q more? Because plus q charge is near to point P, minus q is far away. So E plus q must be greater than E minus q. So net electric field, now we will write net electric field is equal to E net is equal to E plus q minus E minus q. Okay. Or if you are considering the P cap and minus P cap, you can directly add also. Still the minus P cap will take care of the minus sign over here. Okay. So substitute this. E net is equal to 1 by 4 pi epsilon naught. I'll directly take this as common, q by 4 pi epsilon naught times, first thing is E plus q ka point 1 by r minus a the whole square minus 1 by r plus a the whole square and P cap. Okay, even if you add also, you will get the same thing. Once you get this, next step is start taking the LCM, q by 4 pi epsilon naught, this thing LCM, and here P cap. LCM r minus a the whole square into r plus a the whole square. ऊपर क्या आएगा? Here you get r plus a the whole square minus r minus a the whole square. Okay, once you have done this, I'm quickly going through because it's a revision video. Once you solve this, what do you get? नीचे वाला क्या होगा? R minus a the whole square, R plus a the whole square is like x square y square, which can be written as xy the whole square. So when you do that, you get r minus a into r plus a whole square. Okay, above you get r square plus a square plus 2ra minus r square minus a square plus 2ra. Okay, I hope you have understood that step. It's really simple. Okay, let's move on. After this, what happens? The next step is, you can see plus r square a square minus r square a square get cancelled, and here you get q by 4 pi epsilon naught 4ra, ऊपर p cap है वो भी लिख लिया, नीचे r square minus a square the whole square. This will be the step that we get. I hope you understood. We have used a minus b into a plus b is equal to a square minus b square here for the denominator. Okay, hope you understood. Now q by 4 pi epsilon naught, q let us remove it from here. Okay, we'll write one q here, and then I'm sorry, after this what happens is, just put the next step. Okay, he's not showing it because of the page gap. 4 can be written as 2a into 2, r as it is, p cap as it is, by r square minus a square the whole square. Okay, this can now be written as q 2a and p cap together becomes vector p. We know that vector p is equal to q cross 2a times p cap. Okay, so 1 by 4 pi epsilon naught vector p along with a 2 and an r divided by r square minus a square the whole square. This is your formula, and then we move forward. E net is equal to, we can write r is much more greater than a, so r square minus a square becomes r square itself. So 1 by 4 pi epsilon naught 2p by r par 4 आएगा, ऊपर r आएगा, cancel होके 3 आएगा. So the final equation what you're getting here is E net is equal to 1 by 4 pi epsilon naught 2p by r cube. This is your formula which you're getting for axial line of for a dipole, any point on the axis. This is the formula. I hope you have understood. Just have a look how we have done the thing so that it becomes easier. Upcoming derivations I'll try to do it even more faster. Okay, so here first thing what we did, we took the charges, distance, the vector, and then this distance p r. Initial explanation I have told you how to do it. First came the definition, then we went writing e plus q and e minus q, then we told net is equal to e plus q minus of e minus q, एंड देन वी स्टार्टेड सॉल्विंग. मेन थिंग वॉज राइटिंग दिस, टेकिंग द एलसीएम, नीचे वाले को ए बी द होल स्क्वायर फॉर्म में लिखना, फिर ए प्लस बी इंटू ए माइनस बी यूज़ करना, ऊपर टुकड़े करके वी शुड ब्रिंग वेक्टर पी, finally coming to expression and then saying r is much more greater than a, we can avoid a. So that's how you get 1 by 4 pi epsilon naught 2p by r cube. I hope this is understood.